Hey there, gang. In the last video, we reviewed how to add and subtract fractions with like denominators. In this video, we'll take a look at how to do that with unlike denominators. In order to do that, we'll need to review what a least common multiple, or LCM for short, is. In order to add or subtract fractions with unlike denominators, you have to be able to find the LCM of the denominators. And so we'll review that here with a couple of examples. Number one, we're to find the LCM of 3 and 5. The LCM is the smallest number in both lists of multiples for those numbers. And so the multiples of 3 are 3, 6, 9, 12, 15, 18, etc. And for 5, it's 5, 10, 15, 20, 25, 30, etc. Now, for most of these problems, you should be able to do this without listing the multiples out, but I just want to remind you of what multiples are. So in this case, the smallest number that's common in both lists is 15, so the LCM of 3 and 5 is 15. For 8 and 20, the multiples of 8 are 8, 16, 24, 32, 40, 48, etc. And for 10, it's 10, 20, 30, 40, 50, etc. Basically any number that ends in 0. And so the least common multiple here is 40. So notice the LCM is not always the product of the two numbers. For number 1, 3 times 5 was our least common multiple, 15. But 8 times 10 is 80. 80 is a common multiple, but it's not the least common multiple. All right, and then for number 3, 6 and 21, I want to show you a different way you can also find least common multiples, and that is using prime factorization. So if I wanted to do the prime factorization of 6, I could use a factor tree. 2 times 3 is 6, and so its prime factorization is 2 times 3. And then for 21, I know that 3 times 7 is 21, so that's 3 times 7. Well, both of those numbers share a factor of 3. So my least common multiple of 6 and 21 is going to include what they share, which is 1, 3, times anything that's left over. So we have left over here a 2 and a 7. Again, those are factors of 6 and 21. So if I multiply the shared factors times the unshared factors, 2 times 3 times 7, I get the least common multiple of 6 and 21, which in this case is 42. So that's another way to find LCM, as opposed to just listing the multiples out, is to use prime factorization. All right. So the point of all that was to be able to find least common denominators when adding and subtracting fractions. So I've expanded the steps for adding and subtracting to include what you need to do when the denominators are uncommon. We're still going to write all mixed numbers as improper fractions. Then we'll determine the LCM of the denominators and rewrite the fractions using the LCM as the denominator. Once we rewrite the fractions and adjust the numerators, then we'll add and subtract and simplify as we did in the last video. So let's look at these examples now with the fractions. In number 4, we have 11 ninths plus 2/3. So I don't have any mixed numbers here. I can skip step 1. And step 2 says to determine the LCM of the denominators. So here, my denominators are 9 and 3, and so we need the LCM of 9 and 3. Well, you can probably do that in your head. The LCM of 9 and 3 is 9. And so I need to make sure that both of my denominators become 9. Well, the first fraction already has a denominator of 9. Okay, so I can leave that fraction alone and just rewrite that as 11 ninths. My next fraction has a denominator of 3, and I can turn this denominator into a 9 by multiplying it by 3. Whatever I multiply the denominator on a fraction by, I must multiply the numerator by. So I have to adjust that numerator as well to keep the value of the fraction the same. And so in this case, that fraction now it gets written as 6 over 9 as opposed to 2 over 3. So it's still the same size, we're just changing the denominators so that we can add these fractions together now. So now that my denominators are common, then I can do this like I did in the last video. So we have the numerators 11 plus 6, and the denominators we're going to keep 9. 11 plus 6 is 17, and so this becomes the fraction 17/9. Again, we want to reduce if possible. However, this fraction does not simplify, and so this is our answer. Okay, number 5, let's look at our denominators. We have a 6 and an 8. The LCM of 6 and 8 is 24. So I need to multiply both denominators in order to get a 24. Well, the first fraction has a 6 as the denominator, so I can multiply 6 times 4 to get 24. Same thing for the numerator. So this gives me the fraction negative, don't forget to keep the negative sign, 20 24ths. My second fraction, I need to multiply the denominator by 3 in order to get a 24. And so that means I'll multiply the numerator by 3, and this becomes a plus 9 24ths. So we've made our denominators common, so now we can apply the steps that we did in the previous video. So we're going to keep the denominator as a 24, and then we'll write the numerator as an addition or subtraction problem with integers. So remember, this is a negative 20 here. That negative sign goes with the numerator, plus 9. So we have 20 negatives and 9 positives. We're going to take away in this case, and we'll have a negative 11 for our numerator. So negative 11 over 24. I cannot simplify that fraction, and so that would be my answer, negative 11 24ths. All right, looking at number 6, this time I have mixed numbers, so I'm going to rewrite my mixed numbers as improper fractions first. 5 1/8 as an improper fraction would be 41/8. 1 1/20 as an improper fraction would be 21/20. I also see a double sign there in the middle, so let's take care of that. This is a minus negative, and so we know that becomes a plus. So this problem is rewritten in the first step as 41/8 plus 21/20. Next, I need to find the LCM of 8 and 20. The LCM of 8 and 20 is 40. I can do that by listing the multiples or doing my prime factorizations. And so for my first denominator, 8, I need to multiply it by 5 to get 40. So I'll do the same thing with my numerator. So 41 times 5 is 205. So this is 205 over 40. My second denominator, 20, I multiply it by 2 to get 40. And so that fraction, when I multiply 21 by 2, will become 42/40. So now I'll add my numerators. I'm keeping my denominator 40. So this is 205 plus 42, and that gives me 247/40. All right, number 7, I have mixed numbers again, so I'm going to rewrite those as improper fractions. So this is 49/4 minus 27/5. So I need the LCM of 4 and 5. The LCM of 4 and 5 is 20. So I'll multiply my 4 by 5 here, and then my 49 by 5 as well. 49 times 5 is 245. So this is 245 over 20. For my second fraction, I need to multiply that denominator by 4. And so I'll have a 27 times 4, which is 108. So we're taking 245/20 minus 108/20. So now I'll keep my denominator as 20. My numerators, it will be 245 minus 108. And when I subtract those numerators, I get 137. So this becomes 137 over 20. All right, number 8, negative 5 minus 2 1/3. Negative 5 is a whole number, but we'll still write it as an improper fraction. And so it's going to be negative 5 over 1. And then my mixed number 2 1/3 can be rewritten as 7/3. So we have negative 5 over 1 minus 7/3. The LCM of 1 and 3, that's pretty simple. It's 3. So I need to change my 1 to a 3 by multiplying by 3. This gives me negative 15/3. And then I have minus 7/3 still. So I'll keep my denominator as 3. And then the numerator, it's going to be negative 15 minus 7. So we have 15 negatives and 7 negatives. We'll add those to get negative 22. So this is negative 22/3. All right, 3 1/3 plus negative 1 1/2. As a mixed number, 3 1/3 is 10/3. And then as a mixed number, 1 1/2 is 3/2. Double sign, let's take care of that. Plus negative means minus, so this is 10/3 minus 3/2. The LCM of 3 and 2 is 6, so I can multiply this first fraction by 2 in the numerator and denominator. It would become 20/6. And then my second fraction, I'll multiply by 3 to get a minus 9/6. So we'll keep the common denominator of 6 now, and then we have a 20 minus 9 in the numerator. 20 minus 9 is 11, so this becomes the improper fraction 11/6. All right, finally we have an application, number 10. Margie had 4 2/5 pans of lasagna. After a party, she has 1 1/2 pans left. How much lasagna, was eaten at the party? So she's starting out with a total of 4 2/5 pans. And then some of that is being taken away because people are eating it. And then she's left with 1 1/2 pans. So pick up on keywords in problems. Anytime you see that word left, it usually implies a subtraction problem, and that's what we have here. We're taking away lasagna from an original amount, and so we need to figure out how much was taken away by subtracting. So this problem is 4 2/5 minus 1 1/2. And so that will tell us how much was eaten if we do this subtraction problem. So let's change those mixed numbers to improper fractions one more time. 4 2/5 becomes 22/5, and 1 1/2 becomes a 3/2, so we have 22/5 minus 3/2. Our LCM of 5 and 2 is 10, so I can multiply by 2 on my first fraction to get 44/10. And for my second fraction, I'll multiply by 5 over 5 to get a minus 15/10. So we have 44 minus 15 in the numerator. 44 minus 15 is 29. So we get the improper fraction 29/10. Let me move up here. For the answer. Now, it's a word problem. Remember, for word problems, we want to give our answers in mixed numbers just because we use those more often in examples like this than improper fractions. So 29/10 as a mixed number we can find by dividing. So 10 goes into 29 2 whole times with the remainder of 9. So this would be the mixed number 2 9/10. And our units, which we need to include for word problems, is pans. That's what's left over, or that's what was eaten at this party. All right, any questions over this video? Make sure you've written those down so that you can ask those the next time I see you in class. Until then, have a nice day. You're all wonderful people.